So quick review, an expression is something that does not have an equal sign, so we can either simplify or evaluate an expression. So a radical expression is an expression that involves a radical sign. And remember that a radical sign is just another name for the square root sign. So a radical expression is one that has a square root sign. The horizontal bar of a radical sign is a grouping symbol. Now, we've talked a lot about grouping symbols. Remember, grouping symbols come first in order of operations. It's like a parentheses or the fraction bar or the absolute value bars. So that's why it really does matter how far the square root sign extends, because everything under the square root sign has to be done first. So when you evaluate an expression, a radical expression, you will evaluate the expression under the radical sign before finding the square root. Okay, and I think that after we do a couple examples, that might make even more sense. But just like when we did absolute value equation or expressions, and you had to solve what was inside the absolute value bars and then take the absolute value and then do anything outside, it's the same here. You need to evaluate what is under the radical sign or under the square root sign, then take the square root and then do anything on the outside. So here's our first example. Evaluate 5 times the square root of a squared minus b. All right, so just as always, the first thing we're going to do is we are going to plug in a and b. All right, so this is 5, and remember when there's no operation, we know that's multiplication. So 5 times a is 6, so this would be 6 squared minus 27. Okay, so we need to first do what is under the radical sign. Under the radical sign, I have an exponent and subtraction. So I'm just following order of operations, and I know exponents come first. So 6 squared would be 36. And then I'm going to do 36 minus 27, and that is 9. Then I'm going to take the square root of 9, which is 3, because 3 times 3 is 9, and then 5 times 3 is 15. And again, here's another good example where it's okay to just take the positive root. Technically, the square root of 9 is plus or minus 3, but you can just take the positive root as we're practicing these. You only have to give both roots if it specifically asks for that. All right, let's practice some more. So in these, a is 16 and b is 9. So again, the first thing we do is plug in a and b. On number 1, remember when there is not a number there, we can always add a 1. And I'm going to do that just to make it a little more clear. I'm going to make this negative 1 times the square root of 16 plus 9. Again, this really is just asking us for the negative root instead of the positive root. So I first have to do what is under the radical sign, which is 16 plus 9, that is 25. Then I take the square root, so the square root of 25 is 5, because 5 times 5 is 25, and negative 1 times 5 is negative 5. So why don't at this point you pause the video real quick, try 2 and 3, and then press play to check your answers. All right, go ahead and check your answers with mine. Notice on each of these that I did what was under the radical sign, following order of operations, then took the square root, then did anything that happened to be on the outside. All right, the last thing we're going to talk about in this lesson is solving equations where we have to use a square root. Okay, now before we jump into equations, let's do a quick review about inverse operations. When we've solved equations in the past, we've talked a lot about inverse operations, and remember we've talked about how addition and subtraction are inverse operations, multiplication and division are inverse operations, and they're inverse operations because they undo each other. Well, today we're going to learn about another pair of inverse operations, about things that undo each other. And that is that taking the square root of something that is squared equals whatever that something is. In other words, squaring something and taking the square root are inverse operations. Let me try to show you with an example. Okay, think about this. 5 squared is 25. The square root of 5 squared, well, 5 squared would be 25, and the square root of 25 is 5. So do you understand that the square root of 5 squared is just 5? In other words, taking the square root of something and squaring it undo each other. Okay, now that's going to be important to us as we solve equations here. So you see a word problem in your notes. Then, if you could down below add these next 3 examples, because there's going to be problems like this on your homework, so I want to make sure you understand how to do these. And we're going to actually start with my 1, 2, and 3 down below, and then go back to the word problem as our last one. Okay, so for example, on number 1, if we are trying to figure out what x is, not x squared, but we want to know what is x, we have to figure out what squared is 100. Now this one you might be able to do in your head, but I still want you to show how to do it because the equations will get more complicated. And the way that we undo that x squared is to take the square root, because the square root of x squared is x. And we know with equations that whatever we do to one side, we have to do to the other side to keep it balanced. So we have to take the square root of 100, and that's 10. Again, technically it could be plus or minus 10, but unless it specifically asks you for both roots, you can just give the positive. Okay, now look at number 2. This one got slightly more complicated, but we're really just applying what we already know about equations. Okay, so my goal is to get x by itself. So I've got to move things away from the x. So I have a minus 4, so the first thing I'm going to do is add 4. That gives me x squared equals 49, because again, I have to add 4 to both sides. And now I don't want x squared, I just want x. So to undo that square, I'm going to take the square root. Whatever I do to one side, I have to do to the other. And the square root of 49 would be 7. Now, I am not going to make you go through and do a check step on these, but you might want to do a quick one in your head to see that this works. Let me show you. Do you understand that if you plugged in 7 and did 7 squared minus 4, it would give you 45, because 7 squared is 49, and 49 minus 4 is 45. Again, you do not have to do the check step, but not a bad idea to maybe do a little one in your head. All right, last one in this set, number 3. We have 3x squared equals 108. So I want to get the x by itself. What operation's happening between the 3 and the x squared? Well, it's multiplication, so I'm going to start by undoing it with division. I'm going to divide each side by 3. That gives me x squared equals 36. You're welcome to use your calculators to make that division easier. And then I don't want x squared, I just want x, so I need to take the square root of each side, because the square root of x squared is x, and the square root of 36 is 6. So my answer is x equals 6. And again, you don't have to do a check step, but you could to make sure that that is the number that would give you a true statement. This would be 3 times, in this case, 6 squared. And because order of operations, you do exponents first, so 6 squared would be 36, and 3 times 36 would be 108. So you see that that would give you a true statement. All right, let's do the last word problem. An amusement park ride includes a free fall drop of 272 feet. You can use the equation d equals 16t squared to determine the time t in seconds that it takes a dropped object to fall a distance of d feet. So how long does the free fall part of the ride take? Well, if this is our equation, d equals 16t squared, and the distance is 272, we're going to solve this just like we did these previous ones. So right now I want to get t by itself. So I first need to get rid of that 16. It's 16 times t squared, so I'm going to undo that multiplication with division. So I'm just going to make it easy, type into my calculator 272 divided by 16, and that is 17 equals t squared. I don't want t squared, I just want t, so I'm going to take the square root of both sides. Now, I know right away that 17 is not a perfect square, so when I take the square root of 17, I am going to get a decimal, and that's fine. Just remember to always round to the nearest hundredth, so I would get 4.12, and then it's a word problem, so I do need feet. Okay, well, I'm trying to find time in seconds, so it would be 4.12 seconds. You solve them just the same way we did the ones below. All right, I know that was a little bit longer lesson than normal. We had a lot to cover because we talked about what a square root is and expressions and equations. But since we needed to kind of lay the foundation, this video was a little bit longer than the other ones will be. All right, you can move on to your homework now. I hope you have a fabulous day.